Hey everyone, welcome to homework 4.12. Today we looked at graphs and what happens when we change the coefficient of a quadratic function and also what happens when we change the constant. So we're going to match the graph with the quadratic it represents. So the first one says x squared. That's our basic original quadratic, and so we are going to see, let me get my pen working, that's graph B, right? Because it starts at the origin, it goes up, and it's at a pretty normal looking rate there, not stretching too far up or, stretching out wider either. And my computer is freezing, so let's just give this a second. Okay, and we are back. So graph B is our first one. And then we were going to look at x squared plus 5. So here we should find a graph where it's going up 5. And so that looks to be this one right here, because our vertex is at 5, whereas this one, our vertex is at 7. So that helps me a little bit with graph D. And then also this means that graph C is x squared plus 7, because we see that both the y-intercept and the vertex being at 0, 7. And then, so that must mean that this is graph A, but let's just double check. Yes, it's moved down 3 units or translated down 3 units. All right, the two equations, y equals x plus 2 and x plus 3 times x plus 3 and y equals x squared plus 5x plus 6 are equivalent. Which equation helps find the x-intercepts most efficiently? That would be the first, which is in factored form. Because we can see that the values that would make that 0 would be -2 and -3. Which equation helps find the y-intercept most efficiently would be the second, or standard form, because 6 is the y-intercept. All right, number 3. Here is a graph that represents y equals x squared. On the same coordinate plane, sketch and label the graph that represents each equation. So here we're looking at -4, so it's going to be more or less the same curve and everything, but our vertex is going to be at -4. Here we have a negative, so it's going to flip upside down, and then it's plus 5. So I'm going up 5, and then I'm also flipping it downward. So I'll label this as y equals -x squared plus 5, and then this other one is x squared minus 4. So select all equations whose graph has a y-intercept with a positive y coordinate, meaning that the y-intercept is here, right? So this is -2, that's negative. This is 0, so that's neither positive nor negative. This one would be, so here's another case where we see the square outside of the parentheses, so you should be listening to this part with the volume up, because I've gone over these in the homework a few times. All right, so we have x minus 1 squared means that the whole thing is x squared times, x minus 1 times x minus 1, because it's x minus 1 all squared, right? And so this would mean that when I multiply these to create our standard form, I would get x squared minus 2x plus 1. So this would have a positive y-intercept. Here we have -5, that's negative. Here, again, we would get x squared plus 1x plus 2x is plus 3x plus 2. So that is positive. Describe how the graph a of x equals the absolute value of x has to be shifted to match the given graph. Write an equation for the function represented by the graph. So this is a absolute value situation, right? And as Lena said today, they're very closely related in the way that the graphs function. So if this is shifting up, it looks like to 3, we would have that plus 3 on the outside of our modulus bars. But then notice that we've also moved to the right 2. So this would be -2. And the reason it's -2 is because if I put in plus 2 here, 2 minus 2 gives me 0 plus 3, right? And so that would be the point right here. That vertex is 2, 3. And if I plug 2 in there, 2 minus 2 equals 0. plus 3 equals 3. So that would give us the actual point. If I were to write x plus 2, this would then be 2 plus 2 is 4, is 7, and so that would not be accurate. And also, this is the same as x minus a negative 2. So a negative 2 would mean we were going this direction. Okay, so oops. All right. So here is the graph of the function g given by g of x equals a times b. What can you say about the value of b? Explain how you know. So I see that this is decreasing, right? So this is decay. And this is a review of exponential functions, because see the exponent is an x or a variable. So this is decay, which means that b has to be between 0 and 1, right? It's a decimal or a fraction because it is decreasing, and what is left is a percent of what originally existed. Number 7, what are the x-intercepts of the graph that represent this equation here? So here you can see that we can set this up as x plus 1 equals 0 and x plus 5 equals 0. This is why the x-intercepts are called zeros, because they equal 0. So I'm going to subtract 1 on both sides and we'll get x equals negative 1. Subtract 5 on both sides and we'll get x equals negative 5. And so we know that our zeros are negative 1 comma 0 and 5 comma 0. What is the x-coordinate of the vertex? So if my, negative 5, sorry, I forgot the negative there. All right, so then if I'm looking for the vertex of, I'm looking for the point between those two. So negative 1 plus negative 5 divided by 2 is negative 6 divided by 2, which is negative 3. If you wanted to, well, it says to sketch a graph, so let's go ahead and do that anyway. We're going to negative 1. What's going on? Come on, pen. Oh, that's why. Okay. So negative 1, 2, 3, 4, 5, 6. So negative 1's here. Negative 1, 2, 3, 4, 5. Negative 5 is here. So I have one x-intercept here, one x-intercept here. And then I'm looking for the middle point between them. So that would be negative 3. And I can draw a dotted line here to help me note that that's the axis of symmetry, right? That's where the graph would reflect on itself. And this is over 2 and over 2, right? And so I can test that and I see that negative 3 works, all right? So if you're not sure, you can graph it. So that's the x value, but now I need to find the y value. So I'm going to go back and I'm going to plug it in. Because remember, if you have one, if you have x or you have y, you can find the other one. So I'm going to plug that in, and we're going to do negative 3 plus 1 times negative 3 plus 5. And that is negative 3 plus 1 is negative 2 times 2 is negative 4. So this would be negative 3 comma negative 1, 2, 3, 4. About here would be our vertex. And so now I can sketch a little graph here. Now, just as a side note, looking at this, we can see that my y-intercept would be positive 5. And so that makes sense because it looks like this would cross above the x-axis. And so we can sketch a nice little graph of that there. Number 8 says determine the x-intercepts, the vertex, and the y-intercept of the graph of each equation. So we're doing exactly what we did above here, except with different equations and numbers. So x-intercepts, x minus 5 equals 0. We're having this issue again, that's fun. And so therefore x equals 5. X minus 3 equals 0, so therefore x equals 3. So now we have the x-intercepts of 5, 0, 3, 0. And then that means our vertex would be 5 plus 3 divided by 2, which is 8, divided by 2, which is 4. So our vertex would be 4, something. We would have to plug in the 4. So let's plug in the 4. 4 minus 5 is negative 1. So 4 minus 5 times 4 minus 3. I recommend that you write it this way because it'll just be easier for it to look at. Negative 1 times 1 equals negative 1. So negative 1 is the y value for our vertex. And then the y-intercept, again, we would need to put this into standard form. So we would get x squared minus 5x minus 3x, or minus 8x, and then negative 5 times negative 3 is positive 15. And so our y-intercept then is 0, 15. Here, this is a factor, and then the second one is a factor. So I have 2x equals 0, and 8 minus x equals 0. If I divide both sides by 2, x equals 0. Now here, you might be a little tripped up because of this negative x. We can add x to both sides to make it positive, and we'll get x equals 8. And you can test that out. If you plug in 8 minus 8 equals 0, that is true, so we know that works. So we have 0, 0, and 8, 0. Now to find the vertex, again, we're going to add 0 plus 8, divide by 2. All kinds of fun things are happening here. And then we're going to get 4. So we have another vertex with an x value of 4. But this time, we are going to have a different y value, right? So let's take a look and see what that would be. By plugging in 4, we have 2 times 4, and then 8 minus 4. So we get 8 times 8 minus 4 is 4, so 8 times 4 is 32. 32 is our vertex, 4, 32. And then our y-intercept, if we're going to look at this in standard form, we would rewrite this as 2x times 8 is 16x. And then 2x times negative x is negative x squared. So, come on, pen. Which means that there's no constant. There's no constant. That means that the y-intercept is 0, 0. It does go through the origin, and we see that here with the x-intercept as well. So in this case, it's both the x-intercept and the y-intercept. All right, number 9 is a practice of review. If we have stack A increasing by 20% and stack B decreasing by 20%, in the second year, stack A decreased in value by 20% and stack B increased by 20%. Was one stock a better investment than the other? Explain your reasoning. So let's say if we have stock A, let's say it's worth 100, okay? We're just going to give it a value so that we can make a comparison. And it increased by 20%. That means our factor is 1.2, right? Because it increased by itself plus that 20%. And then we have stack B, which was, we'll say 100, and it decreased by 20%, which means it retained 80%. So let's see what happens here. If I have 100 times 1.2, we'll get 120. So now this is 120. And then it decreases by 20%. So then we have 120 times 0.8, which gives us 96. Ooh, interesting. Okay. So then if we have 100 and it decreases to by 80%, or to 80% rather, by 20%, it decreases to 80. But then if I take 80 and I'm now increasing it by 20%, I'm going back up to 96. So interestingly here, they are the same. All right. What is the graph of the equation y equals x squared minus x minus 6 in the xy coordinate plane? So this is an example of a PARCC question that has been asked in the past. The reason this question works so nicely is that we see that we have a positive x value, or x squared value for ax squared. Our a is positive, which means it's going to be facing upward, a smiley face. That helps me to eliminate c, and it helps me to eliminate d. Then I see that I have negative 6 as my y-intercept. So I can look and see which of these has a y-intercept of negative 6. Well, it looks like B has a better y-intercept of 6, but let's see if there's another way I can test it to make sure. So one way that I can test it is I can plug in a value for my x-intercept and see if that works. So this one has x-intercepts of negative 3 and 2. This has an x-intercept of negative 2 and 3. So if I plug in negative 2, let's try that. So negative 2 squared minus negative 2 minus 6. This gives me positive 4. This gives me positive 2 minus 6 equals 0. That one works. And so that tells me that this one, B, is probably going to be the best. I can check 3 too. So 3 would be 9 minus 3 is 6 minus 6 is 0. That works. If I were to plug in negative 3, I would get 9 minus a negative 3 is plus 3 minus 6. It would be 12 minus 6 is 6. That does not give me a 0. So that's not a point that works. And so therefore we know it's not A. Now next week, we're going to be learning another way to look at these. You've learned that if you have, for example, x plus 1 times x minus 2, that you have to multiply everything in the parentheses by everything in the other parentheses. But we can also work backwards and we can factor. So the equation x squared minus x minus 6, let me make sure I have that right, yep, can be factored into x minus 3 times x plus 2, which tells us that our zeros are 3, 0 and negative 2, 0. And I can know this because negative 6 has 2 factors, negative 3 and 2, or negative 2 and 3. It says several factors. I think I said 3. It has several factors that we can use, but we need it to add up to equal negative 1x. So a negative 3 and a positive 2 will give us a negative 1. And so that's how I'm able to reason through what that might be. We'll be looking at that a little bit more next week, but this is just to get you thinking about it. All right, the last 2 questions are also park released items. So these are actual questions that were released on the park. If you have this as your equation, it says the function r of x is defined as r of x equals k times s of x, where this is s is x right there, where k is a constant. So it's saying we're multiplying something times this whole equation. Which statements about the graph of s of x and r of x must be true? So when k is less than 0, the vertex of the graph of r of x is a minimum. Meaning if k is negative, if I multiply the whole thing by a negative, would this have a minimum or a maximum? Well, please make sure you're listening. Listen here, in case any of you are just watching, okay? Listen. So if we multiply this by a negative, that means that it curves down. Because a negative coefficient, right, negative x squared plus 6x plus 9 makes the graph flip upside down. That means that this vertex is not a minimum, but a maximum. So our best answer here would be B, because it should relate to this curve, and it being a negative coefficient means it's going to flip upside down, and that means that it has a maximum and not a minimum. It says when k of, so we know for A and B which one to choose. Let's look at C and D. For C, it says when k is greater than 1, the graph of r of x is a vertical stretch of the graph of s of x. So if it's greater than 1, so for example, if it was 2x squared plus 6x plus, if I multiply the whole thing by 2, this would also change. So 12x plus 18, right? But if this is changing to be greater than, would it stretch up and be skinny, or would it be wider? Okay, so this one would be vertical stretch. That 2 means it's increasing at a faster rate, so it's going to go up faster, right? And so that U shape is going to be skinnier, and we call that vertical stretch. This is called vertical compression because it's as if it's being pushed down, compressed, or flattened. When 0 is less than k is less than 1, meaning a fraction or a decimal between 0 and 1, the graph of r of x is a vertical stretch of the graph, or is it vertical compression? So this is the opposite, right? If it is 1/2 x squared plus 3x plus 4.5, then this 1/2 means that we have the vertical compression. It's flattening it out because it's not increasing as quickly. You can think about that in terms of your exponential functions if that helps. You know that when that factor increased, it was a much steeper curve, right? And then the smaller it was, then that flatter curve happened. So in this case, you should have selected then B, you should have selected C, and you should have selected F. For part B, the graph of s of x is translated to produce the value of t of x, where t of x equals x squared plus 6x plus 13. All right, so we have a new equation now. Which is a correct description of the translation? So the original equation was x squared plus 6x plus 9. So the only thing that we've really changed here is that we've shifted, right? Our y-intercept is now going up 4, right? So it looks like there is now an increase of 4 units. And so this tells us and helps us to see that we have, in fact, moved the equation up because we are adding a constant that's increasing by 4. So in this case, we've shifted it by 4. Now I'm going to show you something really quickly too, that here, this would also change our x-intercepts. So in the original equation, we would have, if I were to factor it, 3 times 3 is 9, and 3 plus 3 is 6. So x plus 3 times x plus 3 is our equation. So as I showed you earlier today, when we have the same thing, we have one vertex, and we have one x-intercept, and that is often the vertex. With x squared plus 6x plus 13 now, we would want to think about, well, what times what can equal 13 and add up to equal 6. So that you might be thinking about is a little bit trickier, right? And as you think about that, that's something we're going to be exploring next week with this factoring what these look like. So if you want to get a heads up on that, Google search or go on YouTube and look at factoring quadratics, and that'll give you a little precursor of next week to help you plan for that or prepare for that. All right. Your code word for today is fellow. Fellow is your code word for today. And if you have any questions, feel free to reach out. Otherwise, happy homeworking and see you next week.